So for this question, we're going to be looking at graph sketching. And typically in these graph sketching questions, the interviewer is trying to see how you see a function and how you're going to use what you already know and your intuition to sketch this sort of graph. Now, the graph you'll be getting will be something you've never seen before, or at least trying to be a graph that you've never seen before. The interviewer is not looking for key facts that you might have seen on YouTube or trying to see if you can impress the interviewer. It's more to see how your problem solving skills are. Now, let's start by sketching this graph by drawing my axes. And let's begin by just labeling my axes here. Yeah, Y, X. Okay, now I like to start with the most obvious things, like for example, X cannot be equal to 0. I know that because the natural log of X is undefined at 0, and since that there's X on the denominator, X can't be 0 there either. Now we also need to think about the domain. So we know that the natural log of X, if you want to sketch this graph, cannot be negative, so we must say X is greater than 0. So anything left hand side of the y-axis, we're not going to worry about. Now, let's think about asymptotes. We know there's going to be an asymptote on the y-axis simply because of the denominator and also because of the natural log of x. So let's just do that now. But now let's think where the function is going to be approaching the asymptote, or yeah, how it's going to be approaching the asymptote as x goes towards 0. Now, if we think about the natural log of x, if we just just do a little sketch of this graph, we know that it looks something like this, and we can see that for small quantities above 0, for when x is slightly above 0 but less than 1, we know that the natural log of x is negative. So it will be in this region here. Now, for when x is less than 1 and greater than 0, x is also positive. So that means the function natural log of x over x must be negative for x being less than 1 but greater than 0. Yeah, and 1 would be the root. Now we have to think about the other asymptotes. So as x goes really large, the natural log of x can't keep up, and I'll show you how I know that. Let's start substituting values on the order of e, so like powers of e. So let's start with x equals e to the 3, which is about 2 cubed, or 3 cubed rather, 3 cubed. So this would be the natural log of e to the 3 over e to the 3, and that equals 3 over e to the 3, which is 3 over 27, which is a ninth. Now let's do something like e to the 4. Y equals natural log of e to the 4 over e to the 4, so that'll be 4 over, I should be approximate sign there, 4 over e to the 4, and that's going to be around 4 over 81. And you can see it's much smaller than 1 over 9. In fact, it's almost smaller. It's almost a squared term smaller than 1 over 9. So you can see it's getting smaller and smaller. And if we start plugging in values of very large powers of e, like e to the 10 over, sorry, natural log of e to the 10 over e to the 10, we could see that this would become 10 over e to the 10, and this just becomes a very, very, very small value, much less than 0.01, or many, many zeros and then 1. So we can then say there will be an asymptote on the x-axis. And well, for values of x greater than 1, we know that this is positive. The function y, it will be positive because the natural log of x for values of x greater than 1 will be positive, and x is obviously positive because we just set x greater than 1. So that means that the function must be above the x-axis between 1 and the asymptote. So that must mean that the function must approach the asymptote above the x-axis, which must mean there is a maximum somewhere, or possibly possibly many maxima and minima, but we sort of expect there to be at least one maximum. And we can find this maximum by just differentiating the function y equals ln x over x. How we're going to do that is just using the quotient rule. If you're not familiar with the quotient rule, you can use a combination of the product rule and the chain rule. But I find it quicker to use the quotient rule. It's simply just squaring the denominator and differentiating the first function, multiplying by the second function, subtracting it with differentiating the denominator, the function in the denominator, multiplying it by the numerator. So this would be dy by dx, and if we simplify this, we get 1 minus natural log of x over x squared, and then we just set dy by dx to equal 0. So I'll just say let dy by dx equals 0, and then this would be 0 equals 1 over natural log of x over x squared. Now we already said x can't be 0, so we're just going to just get rid of this and then just say 1 equals natural log of x. So x equals e, and that's where our maximum is going to lie, at x equals e. Now, if the maximum is at x equals e, then it must be at 1 over e in y, because if we just substitute e into the natural log of x, we get 1 over, well, we get natural log of e over e, and that'll be 1 over e. Now, from the follow-up question, and this is typical of interview style questions, that they'll use something from a previous part to then develop into another question, and in this case, using the graph, try and work out whether e to the pi or pi to the e is greater than the other. Now, I know what some of you might be thinking, and it's that you know the answer already. You know that e to the pi is greater than pi to the e because you might have seen it in some sort of video that's been recommended to you on YouTube. That's not what the interview is looking for, whether or not you just know a fact. It's more of the consequence of what you've already done and using your own sort of tools and what you can deduce from what you've done. Deduction skills, essentially. And you're probably better off starting with your graph rather than just blurting out a fact that's not really going to help anybody. Now, how are you going to use your graph? Well, you'd start off with writing out e to the pi and pi to the, and I'm not exactly sure what the correct notation is, and maybe somebody could correct me on this, but I'd like to write like a greater than sign with a question mark, and then I can start doing some algebra on both sides of it. That's why I've done this. And essentially, I'm going to try and get it into a form, or either of these equations into a form of ln x over x. So either of these expressions into that form here. And one way I can do it, thankfully, because of the base on the left hand side is equal to the exponent on the right hand side, we can take natural logs on both sides. So the left hand side would just be pi greater than question mark e to the ln pi, and then that would be 1 over e greater than over ln pi over pi. Or rather, if you wanted to make it a bit more obvious to you, you can just write this as ln e over e greater than question mark ln pi over pi. And you can actually get rid of the question mark here. Now, why is that? Well, it's a key part of our previous drawing. And I'll explain now. The maximum of the curve, y equals the natural log of x over x, has a maximum when x equals e. And the function outputs a maximum at 1 over e. That means if we were to put in x equals pi, for when x equals pi, the function has to be smaller than where the function was at x equals e. simply due to the fact that the function has a maximum at e. So this must be true, and if that's true, the sign, the inequality sign, which we guess is actually correct, and then we just get rid of the question mark, and we can just draw our arrows up the other way. And then yeah, and the logic works this way. And yeah, we've solved our issue, solved that problem. E to the pi is greater than pi to the e, and we deduce it using the graph.